Alright, question number 8, which is on Kirchhoff's law. Okay, so for this type of questions, always remember to start by I would start by labeling the direction of the current, but in this question it has already been given, which is this one here, and this one here. Okay, so what I would do next is I would first draw the direction of the EMF before I designate a direction of the loop lah. Okay, so what this do is it helps me to decide what is the direction of the loop that I want lah. Okay, so we have two loops here. So this is the first loop, this is the second loop. So actually I forgot to label the direction for each of the resistor, because remember for not junction rule, for the loop rule we have to look at the direction of the current for each of the resistor lah. So we have the current one here going from here, so it's going to go down here, so this will be I1, and then for this resistor here I will let the current point to the left, and of course this side will be pointing up. Okay, so all of this here are I1, so I'm just gonna label them just so that it is gonna be much easier for us to do the calculation later lah. Okay, so if I2 is here, this one will be I2 as well, so it's gonna be pointing to the left, and then we have another resistor here, so this is the third current, so it's gonna be pointing to the right on resistor number 3 lah. Okay, so that is basically all the resistors. Right, so we've labeled the current, and then we have to designate the direction of the loop. So for the first loop, I'm going to follow the first EMF, so it's going to be pointing to the left, which means it will be anti-clockwise. So I would always do a rectangle or a square, depend on the shape of the loop lah, because it is much more easier to see the direction of the loop and the direction of the current lah. Okay, so for the second loop, let's look at the second EMF. It is also pointing to the left, so it's gonna be anti-clockwise as well. Okay, so it's gonna be here, this one pointing down. Okay, all right, so we designate the direction of the loop. So we've did all of the drawing parts, so now we are going to apply the rule lah. Okay, so the first rule is the junction rule, so we are going to look at the junction A here. Okay, so at junction A, I'm just going to write it like that. At junction A, the total current going in should be equal to the total current going out of the junction. So what is the current that is going in? It is I1 and I2, and the current going out is I3. Okay, so this is basically our first equation lah. And then I forgot to read the question. So we have to determine the internal resistance R1, which is this one here, if the current that flows through the 10 ohm resistor, which is this one here, is 1 ampere. So we have been given the value of I3, which is equal to 1 ampere. So it's up to you whether you want to substitute directly the value, but I wouldn't do the substitution yet, because I like to keep it. Oh, actually for this one, it is much more easier if we substitute it directly. Okay, because dia terlampau banyak unknowns, so macam susah sikit lah kalau kita keep it as unknown. Okay, next we have to apply the loop rule. So we apply the loop rule at loop number 1 first. So I'm gonna do it here because you can see the diagram while we are doing the equation. So for loop 1, we are going to apply the loop rule, which is total EMF equal to the total product of current and resistor. Okay. So for this one, it's gonna be the left hand side. We will only be looking at the cell, which is the battery here. So how do we designate, no, not designate, how do we decide whether it's going to be positive or negative? Remember, the direction of loop should be following the direction, oh, it's the other way around. The direction of EMF should be following the direction of the loop for it to be positive. So since both of these are going to the left, it's going to be positive EMF 1. And let's look at cell number 2 for this loop here. It's going to be, this is pointing to the left and the direction of the loop is pointing to the right, meaning it is in the opposite direction. So it's going to be negative EMF 2. Okay, so negative EMF 2, it's going to then be equal to the product of current and resistor. So let's look at the first resistor, which is the internal resistance. We have the direction of the current for internal resistor 1 to be following the direction of the loop. So it's going to be positive. So I'm just gonna directly write down whether it's gonna be positive or negative. Just make sure you are following how I did that. It's basically the direction of the current should follow the direction of the loop for it to be positive. Okay, so let's look at resistor number 1. So that is positive IR1, and then we have the third resistor here, sorry, the second internal resistor there. So it is right, so it is going against the direction of the loop, so it's gonna be negative I2 R2. Okay, lepas to what else? We have the second resistor, so that is following the direction of the loop, so it is positive I1 R2. Okay, so that is basically it. So we have to substitute lah sekarang. So EMF 1 is 15 minus 11 equal to, oh, I forgot to write I1 here. Okay, so sekarang ni boleh kita extract, again I forgot I1 there. So what I'm gonna do is basically factorize I1. We have R1, and then we have capital R1. Oh, actually, let me just think. No, we can't really do that because we are looking for the internal resistance, what am I saying? Internal resistor 1. So we have to keep it that way. So I1, R1, we do not have the value, plus I1 resistor 1, which is 5 I1, minus I2, which is 2.05 I2, plus R2 is 4 I1. Okay, so what we can do is we can add these two together because they have the same unknown. So 15 minus 11 is 4 equal to I1 R1 plus 9 I1 minus 2.05 I2. Okay, so this is basically our second equation. Okay, so now we have to look at the second loop. So loop number 2, again, by applying the second Kirchhoff's law, Kirchhoff's second rule. Okay, Kirchhoff's what is it, loop rule, sorry, I keep forgetting what's the name. I think it's because I am sleepy, but then I have to finish up this video so that you can watch this video next week lah. Okay, so for loop number 2, again, we only have one cell, so this is following the direction of the loop, so it is gonna be positive. And then let's look at the resistor. So we have internal resistor number 2, and it is following the direction of the loop, so I2 R2. And then we have the third resistor, it is following the direction of the loop, so it is plus I3 R3. Okay, so let's substitute the values. So we have 11 for the EMF for the second cell. And then we have 2.05 I2 plus I3 is 1, so this is 110. Okay, so from here we can already get the current for the we can already get the second current. So that is I2 equal to 11 minus 10 over 2.05, which will give you the answer as 0.48. Let me just double check because it's correct. 0.49 lah, 0.487. Should we take 3 decimal point? 0.489 ampere. Take 3 decimal points lah. Sorry. So after we obtain the second current, we can actually substitute it into this equation here, so that we can have only one of the unknowns, which is I1. So I1 tu pula kita boleh guna dari sini. Kita boleh substitute this into here. It's okay. I'm just going to do it so that you can understand it. So first we are going to substitute. Wait. I'm going to do it this way so that you don't get confused. Where is the step? So substitute I2 into equation 2. So this will be 4 I1 R1 plus 9 I1 minus 2.05 0.489. Okay, so we get this equation here, and this is equal to 0.489. So this is equal to 1.002. So from here, actually what we can do is we can let this, oh no, I keep forgetting that I don't have to do that. So this will be our 1 to 3rd equation, where we can substitute, we let equation 1 to be I1 equal to 1 minus I2. So then we can substitute I1 into equation 3. So from here we get 4, 1 minus I2. Wait, no, what am I doing? So we have I2 already. So we can find I1 using I2. Using equation 1 by substituting I2. Okay, so I1 is equal to 1 minus I2, which is 1.002. So it's gonna be equal to astaga, salah lah. 0.489 ba. Sorry everybody. Just bear with me for a while because my brain is getting slow. But it's okay, we can do this. 0.511 ampere. So now we can substitute I1 into equation 3. So if you find a better way of solving this and you get the exact same answer, just follow your steps, because you don't really have to follow how I solve it if you don't understand it. Okay, so now we want to find R1. So this is basically 4 minus 9.511 plus 1.002 divide by 0.511. Okay, I think this is correct. So R1 should be equal to, let me just calculate it to see if we get the correct answer lah. Divide by, so you should get 0.002 0.76, but I get 0.79. It's okay. It's only a few decimal point, not really a decimal point. Sikit saja lah the difference, so it shouldn't really be a problem. So I'm gonna do it 3 decimal points, so it's gonna be 0.789 ohm. Okay, so this is how you should solve for questions that has Kirchhoff's law lah, that the one that you have to apply Kirchhoff's law. Hopefully you are able to solve it without any problem, but if you do, feel free to ask me. Okay, so that is the solution for question number 8.